Okay, let's finish off lessons in 6.4. This is actually kind of a quicker one than the last one. What we were learning last time was basically finding the LCM, multiplying everybody by it to watch the denominators cancel. And I thought, what the heck? Let's do one of their nasty ones right here. Okay, so let's write it out bigger. We have to solve 2 over this thing. Do you remember what we're supposed to do next as I write this out? What's the first thing you're supposed to do here in order to solve these equations? Don't wait for me to say it. You guys figure it out. In fact, once you pause it, maybe look at your notes or some of the homework you're doing. If you know what you're doing, that's great. Yeah, the first thing you're supposed to do, in order to cancel the factors inside the denominators, you have to know what the factors are, so you have to factor. So x plus 4, x minus 2. How do you know that? Well, how do you know I didn't do it in the first place? How do you do this one? Well, 4 times 5 make 9, so x plus 4, x plus 5. All right, and then finally this guy, oh boy, I think it's going to be x plus 5 and x minus 2 will do the trick. I believe so. Let's pretend I knew that, okay? So what I should have done is, you know what, I'm going to write this more spread out because I'm going to come in with the LCD and conquer or cancel everything. So again, 4 over, what did I say again? X plus 5 and x minus 2. Now, some of you guys are going, that's enough for me right there. I just factored 3 trinomials. That's a big deal. That's what makes this a crazy problem. It's one of the last ones. Okay, but once you get going, you're doing pretty good. That's what we want to have happen. So we look at these guys and we realize that I'm going to have to multiply each one by something to make all those factors cancel downstairs. So I look at the first one here and I go, definitely I need an x plus 4 and an x minus 2. Come over here. X plus 4. You know what your brain's going to say? Oh, he doesn't need the x minus 2. Well, if it's all for one and one for all, everybody or nobody gets multiplied. So you gotta multiply everybody by the same thing. And you notice he's got that x plus 5, so I got to sneak him in there. But now I got to back up and go x plus 5 there. And don't forget over here, x plus 4, x minus 2. I hope this guy doesn't have another one. Let's look. X plus 5. Oh, yeah. See? These guys are going to cancel this with that, this with that. These are going to cancel. These are going to cancel. You see the magic of that? So how'd you do that so fast? How'd you do that, Weber? Well, I looked here and I said, I need these 2 guys, but I don't need anything else. But as soon as I saw this x plus 5 here, oh, now I got to add him to the mix. We've got everything we need now to cancel, so let's do it. X plus 4, x minus 2. And who's left? Right there. Write it out. 2 times x plus 5 minus x plus 4, x plus 5. Who's left? Well, the factor he didn't have is who's left, so it's 1 times x minus 2 equals, and finally x plus 4. No, I made a mistake. X minus 2, x plus 5. This guy survives. So write him out. 4x plus 4. And you're in the home stretch now. Basically, you're solving an equation. I'll leave you to it. Let's see who gets there first. I'm gonna beat you. I'm going not as fast as you, and I'm starting to get nervous. But I'm going to take a deep breath right now. Add like terms. Am I ahead of you now? You better take that deep breath. Calm down. Subtract the x over. Subtract the 16 over here. Gone, gone, minus 4 is equal to, right? 3x. So we're getting an answer. X is negative 4 over 3, and that problem is done. Pretty good stuff. Really amazing stuff. We do this a lot in other math classes with other objects besides just x. Like I said, there could be a sine, a cosine. All right, look at these guys now. 2 more problems, and we're done for this video. Also in this section, they decide to to plague us with formulas. And I'm going to do a couple of these problems. I stole them right out of the book. So let's write it bigger. I is equal to the fraction n times capital E all over capital R plus. If you want to pause, you can pause right now. Totally fine. But look what it's saying. Solve for R. So at some point, we're going to be saying, well, R is, but you know what? I don't see any number at all, right? I treat all the letters as if they were numbers. These are actually easier problems. It's just the moves that you have to make. So for example, I might decide to clear fractions. Okay, so I look at the denoms. He's just got a 1. And I look both sides, and all I really need to do is multiply by, how about we multiply by that lone denominator? Can I do that? Absolutely. Everyone does every day in math world. And we get to cancel, don't we? So let's get the right color going on. There's no cancellation here, so this is what we've got. Hey, man, give me my green. Right there. So we have, let's write it, yeah, this is fine. R plus n little r times I is equal to cancel, cancel, NE. You get good at this, you just start throwing things around without all the rigmarole. We're looking for little r. You have different choices. You can divide the I over. Some people do that. I'm going to just distribute the I though. Okay, so I'm going to get r times I plus nr, little r times I is n times E. Again, we're going for this guy. What should we do? People get confused here. Sometimes I'm bewildered. You don't need to be confused. All you have to do is go, well, I'm going to subtract the Ri over here. I'm not going to write it underneath. That'll confuse me. And where we're at right now is cancel. N little r I is equal to NE minus capital RI. Sounds like gobbledygook. This is, I forget, this is an engineering equation or something. And lastly, yeah, we're ready. We're going to divide both sides. I don't care. You can go under, I'm going to go underneath both of them. You can do each one individually or both. I'm going to do it this way. I'm going to get rid of the N, cancel, and the I, cancel, and N and I over here. And I'm going to get an answer of R equals NE minus RI all over NI. I went fast with that, but the steps are identical. It just looks completely different without numbers. You're actually doing less work with this problem than the others. I'm not factoring anything. I'm just clearing and solving, huh? Pretty cool. We can solve for little r. I got one more for you. It's got a lesson in there. This is the last one of this video. So again, you can pause it wherever you want to. That one went kind of fast, I think. This one, there's a lesson. So here we have the following equation. 1 over p, and what are we solving for? Plus 1 over q is equal to 1 over f. They tell us to solve for p. So we want to go p equals. The one thing that doesn't work, and you wish it did, flip over both sides. You can't flip over the left-hand side. It's different. What we have to do instead is, guess what? I'm going to write this again. 1 over p plus 1 over q equals 1 over f. Come in with this and go, I'm going to multiply by something all the way across, and I want to cancel the p, so everybody gets a p. That'll cancel this p, but then there's a q, all right? Everybody gets a q. P times q is your LCM, okay? And f, you get it, don't you? F, F, F. That's weird, but it works. Watch. P cancels. Who's left? QF. Plus Q's cancel. Who's left? PF. Isn't this bizarre? Math is strange. Equals. Who cancels? F. Who's left? PQ. All right. So who are we solving for again? Oh yeah, P. But we got it down to earth. We took this formula and cleared fractions, got it down to earth. Wonderful thing to do. Now this one is from like electronics or something, this particular kind of equation. To solve for P, you have two of them, don't you? Okay, send this guy over to the other side, minus PF, minus PF. Why? You'll see. I just have to show you. So you're left with QF on this side, and on this side is PQ minus PF. It makes sense. You're solving for P. What's the trick here? Weber, what do we do? How do we resolve the two P's in here? Well, two P's in a pod. What you do is you factor it out. That's a fancy move. What do we do now? I tell you, you're going to divide away. Yeah, some of you are like going, oh yeah, okay, Q minus F. Others are like, this math makes me want to not do it anymore sometimes. Yeah, this cancels. Here's your formula. This is the answer. Q times F divided by Q minus F. Isn't that sweet? And that's the final solution here for this particular guy. And I think we're out of it. That is the end of section 4. Take these lessons to heart and do what you can. They all are based upon factoring, multiplying through with these factors, canceling the denominators, and then solving after that. Good luck.